Hey kiddos. So today we are going to begin the process of preparing for the Unit 4 test. Please make sure that you have something to write with and something to write on in front of you. I'm going to go over the directions on how I recommend you taking this practice test. You have two options. Option number one is that you watch all of these videos all together. You take notes on all 20 questions, and then you push those notes aside and you go to the practice test and attempt the practice test on your own, only referring back to the notes if you need them. The second option is to take the practice test as you are watching the videos. So after we complete number one and you've taken down all the notes on how to complete number one, you could then go to the practice test and complete question number one, and then continue in that way. There really is no recommendation at all for you not to take notes, meaning take notes. Make sure that you're copying down the process on how to complete all of these problems. Although the actual test questions are going to be very similar, their answers and the numbers in the problems are not going to be the same. So if you don't know the process on how to go about solving the problems, you will not be able to be successful on the actual test. Okay, so I'm going to get started. You can pause the video if you need to make sure that you have everything ready. I'm going to share my screen, and we're going to get started on the practice test. So question number one off the practice test. By the way, the practice test is named Scanlon 2223 Unit 4 Practice Test. Okay, so question number one says, Tanisha drew a triangle with a side that is 12 inches long and a side that is 20 inches long. Which of the following could be the length of the third side of the triangle that Tanisha drew? Select three that apply. Now, kiddos, remember that when you are asked to select more than one correct answer, the chances of you getting these problems wrong is that much greater. So it's really important that you understand the process on how to solve the problem. I also want to remind you of the triangle inequality theorem. So remember that the triangle inequality theorem tells you that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so what does that mean? That means that it doesn't matter which two sides of a triangle that I choose to add together, their sum has to be larger than the length of that third side. And that's the idea that we're going to be using in this particular problem. So I'm going to go back to the test question, the practice test question now, and we are going to talk about Tanisha. I'm going to go ahead and sketch out a sample of a triangle that she might be working with, just to kind of give those of you who are visual learners an opportunity to kind of look at what we're talking about. So let's just pretend that this is the triangle that Tanisha is trying to draw. And we are given the information that one of the sides is 12 inches long and another side is 20 inches long. So remember that sketches aren't drawn to scale, so it doesn't really matter where I put these numbers. I'm going to put 12 here. I'm going to put 20 here. Okay, and so the goal of this particular question is to figure out how long does this line right here need to be in order for us to create a triangle, a closed shape. So because this is multiple choice, I can do this in a rather simple fashion. What I'm going to do is I'm going to go one by one through my answer selections, and I'm going to pretend that the third length of the triangle, in this particular case, I'm going to start with choice A. I'm going to pretend that this final length of the triangle is going to be 35 inches. And then I'm going to use that triangle inequality theorem to test it and make sure that it's possible. So what does that mean? Well, watch the process. What I'm going to do is I'm going to pick two of the sides of the triangle, doesn't matter where I start. So I'm going to say that 12 plus 20 has to be bigger than the third side. So 12 plus 20 has to be bigger than 35. 12 plus 20 is 32, and 32 is not bigger than 35. Therefore, I know that this could not possibly create a triangle. Right off the bat, I got a false statement. I got something that couldn't work. So I know that this is not one of the correct answers. So I'm going to eliminate choice A, and I'm going to try now choice B. All right, so I'm going to do that same strategy with all of these answer choices until I bump into something that can be created. All right, so choice B says that the unknown length could be 32. So again, I'm just going to start with the same two sides, 12 and 20. Remember that 12 plus 20 has to be larger than that last side of 32. And 12 plus 20 is actually 32. It's exactly 32. And 32 is not greater than 32. It would be equal to. So this is a false statement, meaning that this 32 inches could not possibly be the length of the third side. Continuing on in the process, I'm going to now choose answer choice C. It says that the third side might be 21 inches. So you're going to see how my process now changes. I'm still going to start the same way. I'm going to say that 12 plus 20 has to be larger than 21. And 12 plus 20, we've already decided is 32. 32 is greater than 21. So far, so good. All right, what we've done is we've checked one of the possible combinations. So what I'm going to do now is I'm going to check a second combination. And so what does that mean? Well, that means that I'm going to come over here and instead of checking maybe 12 and 20, I'm going to check 12 and 21. So remember that 12 plus 21 has to be larger than the third side. The third side in this case is 20. And 12 plus 21 is 33. 33 is greater than 20, so this one checks. And so then I've got to check the third set of sides. All right, so I've checked 12 and 20 together. I've checked 12 and 21 together. So the last thing that I need to check is 20 and 21. So 20 plus 21 has to be larger than the third side. The third side in this case is 12. 20 plus 21 is 41, which is greater than 12. That is a true statement. So what does that tell me? That tells me that answer choice C is correct. That all three of those side lengths, when I add any two of them together, is always larger than the third side. So therefore that would create a triangle. I've got one of the correct answers. All right, I'm going to repeat this process using answer choice D to see if I get a true statement on all three scenarios. Okay, so I'm going to erase everything that I've got started. And I'm going to go through and change that third side length of my triangle. So now in this case, this third length is 12. Okay, so we're going to do that process all over again. I'm going to pick any two sides, doesn't matter where I start, and I'm going to make sure that their sum is greater than the third side. So let's try 12 plus 12. 12 plus 12 has to be greater than the third side, which is 20. 12 plus 12 is actually 24. 24 is greater than 20. That checks. So far, so good. I'm now going to check maybe 12 and 20. And the good news is, in this case, I've got two 12 plus 20s, right? If you look at your triangle, you've got two sides that are 12 inches long. So I only have to test that sum once because it's the same thing. All right, is 12 plus 20 greater than the third side? Let me circle this so you know what I'm doing. I'm adding 12 plus 20, and I want to make sure it's bigger than this third side. So 12 plus 20 is actually 32. And 32 has to be greater than 12, which it is. So this one is true. Okay, and if I did it again, I would be using 12 plus 20. So I'm done with that one. D is a correct answer. Now, maybe at this point you get it well enough to kind of just look at the next two answer choices to figure out which other one is correct. But I'm going to go ahead just to prove the point and show you the entire process all the way to the end. At any point during this video, you feel like you understand what you're doing and you don't need to watch the rest of the example, you are free to move to the next question. All right, kiddos, so this one was 12 and 20. Those were the given side lengths. I'm now going to test a third side length here of 9. So let's just pretend that side length is 9. And I'm going to go through that process again of saying that any two sides, let's say maybe 12 and 9, when I add them together, have to be greater than the third side. In this case, the third side would be 20. And 12 plus 9 is 21. 21 is greater than 20, so that one checks out. I'm going to pick two different sides now. So instead of 12 and 9, maybe I got to rewrite those numbers now, bear with me. So this was 12 and this is 9. Okay, so I've tried 12 and 9, so now I'm going to try, let's say, 9 and 20. All right, so I'm going to say that 9 plus 20 has to be greater than 12, and 9 plus 20 is 29, and 29 is greater than 12. That checked. So all I have left to do is to check the third group of numbers. So that would be 12 and 20. And you can just see it. 12 plus 20 is certainly greater than 9. 12 plus 20 is 32. 32 is greater than 9, so that one checked. So 9 inches is a correct response. Okay, so if that third side of that triangle is 9 inches, you will still have a triangle. All right, just to prove that it cannot be F, because again, practice tests are part of us relearning, making sure we understand it completely. And again, we don't know exactly what the actual test is going to look like, so having all this information will be valuable to you. Let's take a look at what the triangle looks like when the last side length is 5. All right, I'm going to do the most obvious part first, just to make it quick. I'm going to test 12 plus 5. I know 12 plus 5 has to be greater than the third side length, which is 20. 12 plus 5 is 17. 17 is not greater than 20. That's a false statement. Therefore, F cannot be correct. So answers C, D, and E in this case create the triangle. We are going to go ahead and move on to question number 2. Question number 2 says a student draws a geometric shape where all the sides are different lengths. Which of the possible following geometric shapes could the student have drawn? Select all that are correct or that are possible. So the key here is really understanding the rules of these different shapes. We are trying to figure out which geometric shapes can have all of the sides different lengths. All right, so that's kind of the key that we're looking at here. I'm going to go ahead and kind of underline or highlight that part. The different lengths is the most important piece. So let's see what you guys remember about these different shapes. A trapezoid. All right, a trapezoid by definition has 2 parallel bases. Parallel means that they go on and on forever and never touch. So an example of parallel bases might look a little bit like that. Okay, and the other thing that we know about trapezoids is that the other 2 side lengths may or may not be the same. They may be the same length, they may not, but they may be the same direction. But this would be an example of a trapezoid. And if I wanted to create a trapezoid, the difficult part here is that it says that all of the sides are different lengths. All right, so in order for me to have a trapezoid, I guess it's easier for us to kind of understand what we would have if everything were different lengths. In order for us to create a rectangle, let's say, we would have 2 sides that are the same length, right? So like a rectangle would have, if I told you that this were 6 units long in a rectangle, this would also be 6. And if I told you that this was 12, this up here would also be 12. All right, so those can't be different. But in a trapezoid, all 4 of these sides can be different lengths. This could be 8. This down here could be 12. This over here could be 6. And this over here could be 4. Right, we could have all different kinds of sides and shapes or side lengths for trapezoids. So a trapezoid is a correct response. All right, let's see what you know about a rhombus. A rhombus is kind of like the shape of a square, except it is squished so that its sides are diagonal. All right, so this would be what a rhombus looks like. I'm going to try and draw it as well as I can. And a rhombus is very, very similar to what we call a parallelogram, but here's the difference. This, if I'm calling this a rhombus, this is what I know. I know a rhombus has 2 sets of parallel bases. So this top and bottom are parallel, and the sides are also parallel. But in a rhombus, I know that all 4 of the lengths of the sides are the same. So if I tell you that this is 6 inches, all of them are 6 inches. A rhombus and a square are almost the same. All right, a square would look like this, where they would all be 6 inches. And a rhombus is almost identical to that, it just doesn't have the right angles. So a rhombus has to have side lengths that are the same. There's no way it could possibly be a rhombus. All right, now we're going to talk about the triangular shapes that could have different side lengths. And so this is really just an understanding of the different types of triangles that we have grouped by their side lengths. An equilateral triangle, by definition, is a triangle where all of the lengths of the sides are the same. That's equilateral. Isosceles triangle, by definition, is a triangle where 2 of the sides of the triangle are the same. That's isosceles. And a scalene triangle is a triangle where none of the lengths of the sides are the same. So this would be, say, 4, 6, and 8. Okay, so your understanding or your memory of these types of triangles is important. A scalene is the only one where all the sides can have different lengths. So the only other possible answer choice here would be D. I do want to remind you that that information is also found on your slideshow in the different types of triangles that we have. And you should see that right here on slide number 20. It tells you the different types of triangles that you could be working with. Okay, we're going to move on to question number 3. Question 3 says the longest side of a triangle is 12 centimeters. Which group of the line segments could form the other 2 sides of the triangle? Select 3 that apply. Well, guys, this question should sound very familiar. We just did the same exact idea on question number 1. It's that triangle inequality theorem. But in this case, they're only giving us 1 length of the triangle, and your job is to figure out what the other 2 lengths could be. Same idea, just kind of written differently. So I think the easiest way to do this would be to take the 2 measurements given as an answer choice and this 12 centimeters, and to kind of sketch out a triangle that might look similar to that. Again, I'm just sketching a random triangle, doesn't matter what it looks like. And I'm going to label the lengths of the sides 5, 5, and 12. And I'm going to do my check to make sure that when I add them together, any 2 of them together, the sum is larger than the third. So we could just start off here by doing 5 plus 5 is supposed to be greater than 12. Maybe I picked these 2 sides. 5 plus 5 is not greater than 12. That's false. So automatically I can eliminate choice A. Okay, we've already done this once. I'm not going to spend as much time this time going through how to approach this problem because I've already retaught you how to do that one time. All right, let's try another one. How about 6 and 6? So if I add 6 plus 6, that's supposed to be greater than the third side length of 12. 6 plus 6 is actually 12. 12 is not greater than 12. That's false, so it can't be choice B. All right, going on to choice C. Choice C says 6 and 7. Okay, so if I add 6 plus 7, it's supposed to be greater than 12. 6 plus 7 is 13. 13 is greater than 12. That's the first check step. Now, because that one worked, I want to make sure I check all of the different types of arrays or ways to put these together. So now I'm going to check maybe 6 and 12. And you could probably just look. 6 plus 12 is certainly greater than 7. And then the third check step would be to check 6. Pardon me, we already checked that one. We would check 7 and 12. You want to make sure you get all 3 different combinations. All right, so now I'm going to check, does 7 plus 12 give us something bigger than 6? So 7 plus 12 is certainly bigger than 6. So this could, yes, create a triangle. So choice C is correct. And remember the directions say to select 3 that apply. So we've got one of the 3. All right, now maybe one of your test taking strategies would be to jump to a different set of numbers. Maybe because as you're looking through your answer choices, you're saying, well, 8 and 9 are pretty close, 10 and 11 are pretty close. Maybe I'll try this biggest one and see if I get a true sentence. And if I don't, then I know what my other 2 answers have to be. That's a good test taking strategy. So let's say this one's 11 and this one's 12. So I'm going to test, is 11 plus 12 greater than 12? You could kind of see right off the bat that that's not a true statement, so it can't possibly be F. So because there are 3 correct answers, I'm going to assume that D and E are also correct. But a good test taking strategy is to check it to make sure you didn't make a silly mistake. So I'm going to check 8 and 9. So real quickly, I'm going to say, is 8 plus 9 bigger than 12? And that is true. And then I might check 8 and 12. Is 8 plus 12 bigger than 9? And that is true. And then I'm going to check 12 and 9, which would be the third combination. Is 12 plus 9 greater than 8? And that again is true. So that just proves that choice D is correct. And finally, to prove that choice E is correct, I'll change those numbers out and put in 10 and 11. All right, so 10 plus 11 is greater than 12. 10 plus 12 is greater than 11. And 11 plus 12 is greater than 10. Those are all true statements, therefore choice E is also correct. Pause the video if you need to. I'm going to move on to question 4. All right, a triangle has side lengths of 10 and 12 inches. The angle across from the 12-inch side has a measure of 65 degrees. Which figure represents this triangle? This is an example of the skill that wants you to create a triangle. So we're just going to follow these rules when we are creating this triangle. We're not given every single piece of it, but we're given enough to know what we're doing. The first part says the triangle has side lengths of 10 and 12 inches. So I'm going to just draw a 3-sided triangle. All of these triangles in my multiple choice answers look similar to each other. So I'm just going to draw a triangle kind of similar to that. And it says that I have side lengths of 10 and 12. It doesn't tell me where they are, but I'm just going to write 10 and 12 on 2 of the sides. This last piece is what's going to make us have to figure out which answer choice is the same. It says the angle across from the 12-inch side has a measure of 65 degrees. So if I find the 12-inch side, which is from here to here, that's where I put my 12-inch side. It says that the angle across from it, so across from it would be right here. That would be the angle that is across from it, right here. This angle has to be 65 degrees. 65 degrees. All right, and so this would be an illustration of one possible triangle that would fit these requirements. So I'm going to go through here now and try to figure out maybe which triangles I can eliminate or find the one that is correct. I'm going to start with choice A. I can tell you right off the bat that choice A is incorrect because they use the number 12 as a degree measurement, not as a side length, so it cannot be A. B shows me that the 65-degree angle is across from 10, not from 12. So answer B is incorrect. Answer choice C shows me that the 65-degree angle is across from 12. That looks right to me, but let me just make sure D is not correct. D is putting the 65-degree angle across from our unknown side length, not the 12 unit long side length, so it cannot be D. C is the correct answer.